before closing part 1, I want to briefly discuss incomplete references. Incomplete means I may be missing many important ones. I'm sorry about this. Okay, so our first part was Jarzynski equality and the second law of thermodynamics. And the basic reference, main reference is this PRL by Chris Jarzynski. And we basically followed this. So, well, you can, this is a very famous paper, and I think you can read it. But anyway, you know the main context. And probably this is the only thing we need for this part, but probably you remember in page 19, we discussed the derivation of one form of the second law of thermodynamics, passivity or Planck's principle, which looks like this. And I argue that you can derive this in a much more general setting. And it was done by Leonard using a technique called measurization. So if you are interested in this, the basic reference is this 1978 paper by Leonard. But if you're really interested in this, this kind of subject, I recommend you to read this beautiful book by Takahiro Sagawa. So it discusses modern extension generalization of this result from modern viewpoint of quantum information. Okay, this is a very well-written book. Okay, about fluctuation theorem, it's a bit complicated. Here, these three are classical references of this subject, and this is not related to what we discussed. This is about non-equilibrium physics, but in a very different context. But anyway, they discovered fluctuation theorem in this paper, and then they understood this very important relation in these papers, and there are many more. Actually, I'm missing many important papers from this early stage. But anyway, I had to mention these early papers. And the very easy fluctuation theorem, actually the version of fluctuation theorem we discussed is something almost trivial. And this version, I think, was first discussed again by Chris Jarzynski. Okay, so, and as for detail balance condition, again, this has a long history. And first of all, this Kramers is a very important physicist. He has done many important things. And the consideration that I gave about this Brownian particle going above this potential wall was discussed by Kramers as a model of chemical reaction back in 1940. Okay, detail balance condition itself, I think, was first introduced by this 1955 paper. I was not born. I'm an old person, but I was not born. And this was introduced by this old paper by Bergman and Lebowitz. And this is nobody else but Joel Lebowitz. He's still active. He's more than 90, but I think he's still active. And yeah, so in this very important old paper, they introduced this very important notion. And the derivation, our derivation of detail balance condition is something I think very standard and well known. And as you have seen, the derivation is essentially the same as the derivation of fluctuation theorem. So I think many people knew about it. And it's hard to pinpoint a single paper in which this was done, but I think this is close to. In this paper, they discuss something very similar. Okay, so that's all for part 1. So thank you for watching. Goodbye and hopefully see you in part 2.